All right, so as it turns out, if you plugged these into our formula, we'd get the exact same answer as in the last example, negative 0.5. Okay, so in this case, demand is inelastic. In other words, the percent change in quantity is smaller than the percent change in price. That's what it means to be inelastic. Okay, so moving on to a more in-depth use of this measure, elasticity of demand, price elasticity of demand. We're going to talk about something called the midpoint method. So you may have learned how to calculate percent changes in some other class or at some other point in the past. And typically it's done by finding the difference between the old value and the new value, and then determining what percentage of that change, what percentage of the initial value that changes. So we use the initial value as sort of a point of reference. So let's think about if we were to use the usual percent change formula, what kind of issues we might face. Okay, so first think about a price decrease from $100 to $80. That's basically a 20% decrease, right? The change is negative 20, and we use the initial value of 100 as the reference point. And so relative to 100, minus 20 is 20% of 100. So it's a 20% decrease. Now think about sort of going in the other direction, starting from $80 going to $100. The absolute change is still 20. It's a positive 20 this time, but the absolute change is still 20 in magnitude. But this time, if we were to use the usual percent change formula, our point of reference would be $80 since that's where we started. Now 20 is 25% of 80. So if we used our usual percent change formula, we would get an increase of 25%. So in other words, depending on where we started from, we would basically get different answers calculating our elasticity if we were to use the sort of standard way of calculating percent change. So that's why in economics, when we're calculating elasticity, we use something called the midpoint method. Okay, and the midpoint method gets us around this issue. So rather than using the initial value as the point of reference, we use the average of the two values as the point of reference. Okay, so rather than calculating percent change in quantity demanded as the change in quantity demanded divided by the initial quantity, we will use the average of the two quantities. And we'll do the same thing with price. So if we use this midpoint method, this is basically what our formulas end up being. Now let me just, I'm gonna pause the video for a second. I'll be right back. I'm gonna set up my doc cam so that I can show this to you. All right, so now that I've got my doc cam set up, the usual way of calculating percent change, right, like I said, is usually, let's just use quantity for right now, is usually the change in quantity, so Q2 minus Q1, and then usually we divide by the initial quantity, right? So that's how we usually calculate percent change in most cases. But as we saw back here in this example, right, we saw that creates some potential issues for us when we calculate elasticities. And so, we don't really want the elasticity to depend on whether we're going from 100 to 80 or 80 to 100. We'd like it to spit out the same elasticity number, regardless of whether we're going from 100 to 80 or 80 to 100. So that's why we're using the midpoint method, okay? So basically, rather than using the initial value here as our point of reference, we're going to be using the average. Okay, so we don't want to use this method here for our percent change calculations. We want to use the midpoint method. So we still do the same thing on the top there. We find the absolute difference, but rather than using our initial value, as a point of reference. We're going to use the average of the two values as a point of reference, right? So Q1 plus Q2 divided by 2. Okay, so there's our point of reference. There is the average. Okay, and we're going to use that for both the top and the bottom. So again, this is where our midpoint method formula is coming from. Okay. So if you're confused about that, feel free to shoot me an email, and I'll try to explain it a little further so that you fully understand that. But this is the method that we're going to use, and this is the method you need to know. So here we go. We've got some numbers for a numerical example. So we've got the old price is $6. The initial price is $6. And at a price of $6, there's a quantity demanded of 15. And then if the price goes down to $4, the quantity demanded goes up to 25. So all we got to do is plug those into our formula here, and we end up, after all the calculating, we end up with negative 1.25. So I encourage you to go ahead and try this yourself. Plug in those numbers into the formula. And try to get to this result on your own. Okay. So yeah, I recommend practicing this as much as you can. This is one of the more difficult concepts in this class. So do yourself a favor and get lots of practice with this. Okay, and as long as you you can make up your own numbers, as long as you make sure that you're remaining consistent as far as the law of demand goes. So, here we see a price decrease, which means that quantity demanded should go up. So just make sure you're sticking with the law of demand, and when price goes up, quantity demanded goes down, and vice versa. But you can make up your own numbers and get a little bit of practice. Of course, I guess if you make up your own numbers, you won't be 100% sure if you're right, but I'll give you some practice items as well. Okay, so just in that case, I'll even give you another practice set of practice numbers here, so you can pause the video and practice this yourself. But suppose that P1 is 10, P2 is 20, and when the price is 10, the quantity demanded is let's say 50. And when the price is 20, the quantity demanded is, let's say 30. Okay, so go ahead. I'll transition over there so you can see that more clearly. Use that as some practice. I'll reveal the answer in a little bit.